Hi, welcome to this paper. It's a predicted paper for the non-calculator in May 2025. It is based on our knowledge and experience of past papers. So no one can tell you exactly what is going to be in your paper, but what we can do is create something that really pulls together the most common things that we see. Now, I have written these questions so they are new. They are not a mashup of other past papers to create this, which makes it a great revision resource because you haven't seen any of these questions. So it will really test your understanding and your knowledge of the maths. So you can download the paper, it's in the description, and you can either set it like a mock, do it quietly, come back to the video, or you can work along with the video, entirely up to you. Please also be aware that the channel has lots of past exam questions that have been created with worked solutions and then grouped by grade. And we also have that for grades 1 to 2, 3, 4 to 5, literally all the way through. So do go and check that out if you want to do a bit of revision, but you don't want to do hours of it. You haven't got time with all the other things going on. Then a quick 10-minute here or 20 minutes there in these playlists is fantastic revision. It really is. I will be creating something for paper 2 and paper 3. So if you have found this useful, please like, please subscribe, and keep an eye on the channel so that as they land, you will be able to find them nice and easily. All right, let's get on with this particular paper. Okay, so 30% as a decimal is 0.3. Percent means out of 100. We've got divide by 100 here. So it's literally 30 divided by 100. We've got to write down the even number. That is 1.6. Numbers ending 0, 2, 4, 6, 8 are all even. 350 centimeters into meters is 3.5. There are 100 centimeters to a meter. Okay, we're being asked to write down a number that is both a factor of 20 and a square number. So let's find the factors of 20 first. That's all the factors. And now we just got to search out that square number. Now there are actually two. 1 times 1 is 1 and 2 times 2 is 4. Either of those would be the correct answer. And I'm going to put 4 down. Square root of 36 is this question when we use the symbol. And what multiplied by itself makes 36? 6. Okay, a many question. So Tyra is planning a trip to the cinema for herself and 3 friends. And the tickets are going to cost £8.40 per person. She also pays for food. She is paying with 2 £50 notes. So that tells me £100. And she gets £43.40 change. We've got to work out how much the food costs. So let's work out the cost of the tickets. It's £8.40 per person. There's Tyra and her 3 friends. So there's 4 people in total. So we've got to do £8.40 times 4. Now, how you choose to do that is obviously up to you. I am going to do it just by column addition. So I know how much the tickets cost, £33.60. Now I've got my £100. The tickets are going to come off of that. Now that's £33.60. So if I add that in, that's my problem. That's quite tricky with all those zeros. I actually prefer to do a count up method. So if I added 40 pence, I would be at £34. And then to get all the way to 100, I would add 66. So when I've taken the tickets off, I've got £66.40 left. I've got to take the change off because that's what I'm getting back to put in my pocket. And when I do that, there is £23 difference, and that must be what the food cost. Okay, we're being asked to work out the size of angle X. So I've got 2 of the angles. I'm going to add those together, which is going to give me 130. And then 180, take away 130 is 50 degrees. I have to give a reason for my answer. And my reason is straight line adds up to 180 degrees. Okay, so the coordinates of point A is 2, 3 along the corridor up the stairs. I've got to mark B with a cross, -4, 2, and then write down the midpoints of AC. So a good way of doing this is to pop this on, measure it with your ruler. Let's pretend it's 8 centimeters. And then you go into where the 4 is. You go to that midpoint and you find the middle. You could also count the squares. We've got 1, 2, 3, 4, 5, 6, 7, 8. So I want to be 4 in, which puts me here, giving me a midpoint of 2 minus 1. Now, the reason I've given all the extra information about maybe measuring the line and getting your midpoint that way is because it's not guaranteed that you'll get a vertical or a horizontal. And if you get a line that's on a diagonal, it can be a lot harder to work out where that middle is. Okay, so the pictogram shows some information about the number of roses sold in a flower shop in each of January, February, and March. So we've got that information, we've got the key, and on the grid, we're being asked to draw a bar chart to represent the information. So the first thing I need to do is work out how many were actually sold in each month. Now the key says a full square is worth 8. Total for January would be 24. If I've got half a square, then I've got 4. So February would be a total of 28. And then March, we've got 2 8s and a 4, giving us 20. Now I've got to work out the best way of using the grid that I've got available to me. I know from my information that I need to go as high as 28. So going up in ones isn't going to work. 1, 2, 3, 4, 5, 6, 7. We can see that. So let's see if twos work. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's not going to work. I would check back in with the numbers and make sure you are going up in something that would be easy to work with on the grid. In this case, they're all in the 4 times table. So I'm going to go up in 4s. And now I'm just going to start pulling everything together. So January has a height of 24. So I'm going to go up to my 24, use a ruler and label. Now the width doesn't matter. I could have just gone up and done 1 square. The width doesn't matter. But what does matter is that I am consistent. So if I've done 2 squares, I must do all of them 2 squares. And that's it. You need to be consistent with your widths. You need to make sure all your heights are correct, your frequencies labeled, and your bars are labeled. Now, there was another part to this question. It was to write down the modal month. Now, modal is the same as mode. So it's the most common, and that was February. So you would write February for the modal month on the dotted line. Okay, question 10. We've been asked to simplify 2b times 6b. Here you just do the number work you can see. So 2 times 6 is 12. And then b times b is b squared. We want to collect the like terms. We've got 15b. And I travel along to find the other b's. I've got 7 of them. And it says take away. So 15 take 7 is 8. So I have 8 b's. And then I've got 4 C's, and I need to add another 3. So I have got a positive set of 7 C's. Now, factorizing, we have to find the highest common factor, the biggest times table that goes into both of these, which is 12. And then you open up your bracket. 12 times D is 12D, and 12 times 3 is is 36. Okay, we've got to divide this fraction, which means we're going to be keep, change, and flipping. So we've got 6 over 7 times 5 over 3. That gives us 30 over 21. And that can be our final answer because they have not said give your answer in any particular way. And when they don't ask you to do anything, then you don't need to do any more. That would work perfectly well. If you did go on, then you can get one whole lot of 21s with 9 left over the 21. That would cancel. They're both in the 3 times table. So we would have 1 and 3 over 7. Okay, we're being asked to find the output when the input is 5. So our input is at the beginning. So we've got 5 going in and it hits times by 3. So we do that, we've got 15. It then travels on and hits a +8. So we do that and we've got the answer 23. On the second part, we've got to find the input when the output is 2. That means we're at the end of this machine with our number 2. When you are at the end of the machine, you will be traveling backwards. And as you travel backwards, you do the opposite because you are traveling in the opposite direction. So the first thing we hit is a take away 8, which is -6. And then we've got a divide by 3. How many 3's can you get into 6? 2. And there's 1 negative in the question. So there's 1 in the answer. Okay, we've got to write down the inequality shown on the number line. The number line is labelled with a P, and I'm going to pop that down first. That goes in the middle. I then have my symbols, and then I have the range, -3 to 1. Now I'm going to start thinking about the circles. If the circle is filled in, it means it can equal the number it's above. If it can equal that number, I need to show part of the equal sign on the inequality. So I've got to pop it on this one because it can equal -3, but I'm going to continue to leave this blank because it does not equal 1. Okay, now when we're solving an inequality, we're going to use the exact same method we use for equations with an equal sign. It's only this that's different. Our method is exactly the same. Now, I'm going to use the methods that I use in class for my students. Obviously, you will have the methods that you've been taught. I use the hopping. So we're going to circle that, throw it over. It's going to land as +7. So we've got 3x, the inequality sign, which is a less than sign. So 3x less than 27. And then we divide through by 3, and x is less than 9. And that would be our final answer. So we're being told there are only blue, red, and yellow counters in a bag. 15% of the counters are blue and 3/5 are red. There is a total of 480 in the bag, and we need to work out how many are yellow. So if we've got a total of 480, the first thing we want to do is find 15%. Okay, so we're going to find 10% by dividing by 10, which is 48. 5% we find by halving our 10%, and our 15% comes from adding those together. So 15% are blue. 3/5 of 480 is our next calculation. Now, we divide by the bottom and times by the top. So I'm going to take my 480 and I'm going to divide it by 5. Now, 5s into 4 don't go. 5s into 48 go 9, remainder 3. And then 5s into 30 go 6. Now, I've done the first step. I haven't got the answer yet. 96 then needs to be multiplied by 3. And again, up to you how that you do this. You might put it into column addition, or you might do what I'm doing. Anyway is fine. And that is our number of red. I'm being asked to work out how many yellow there are. So I'm going to add my blue and my red together. And then I'm going to take it away from the 480. So my final answer would be 120. Now I'm being asked to write the ratio of blue to red to yellow in its simplest form. So blue to red to yellow means the 72 gets written first, and then the 120 is on the end. Now, how you do this is entirely down to your skills with times tables and what you spot. When the numbers are quite large like this, the most sensible thing to do is to divide by 2. Just get them halved, get them smaller, and they may be easier to work with. The 144 is still quite large. You may spot a times table or you may not. They're all even, which means you can divide by 2 again if you would like to, and they are still all even. And you can keep going until you get down to 3.12.5. At this stage here, if you spotted that these were all in the 12 times table, you could have divided by 12 and gone straight to this. There's no kind of rules as to how many times you can or shouldn't do this. You've just got to keep going. It's a bit like cancelling fractions, isn't it? Okay, quite a wordy question. We've got to make sure that we've understood what it is they're asking. We're being told that flour is sold in 1.5 kilogram bags, and we've got a price for that. Barry has 4 bags of flour, and he's got plenty of all the other ingredients. That line is telling me that flour is the significant problem. He wants to make 20 loaves, and we've got to work out how much it will cost him to buy the rest of the flour that he needs. So the first thing we want to do is work out how much flour he's going to need for 20 loaves. The ingredients given are for 1 loaf. So we're going to be doing 20 times 500. 2 5s are 10, and add in the rest of those zeros. So that's 10,000 grams. We're now going to change this into kilograms because our bags are in kilograms. Grams to kilograms is 1,000. So we're going to divide through by 1,000. And that is going to give us 10 kilograms. We know he already has 4 bags. So let's work out what that is. So 4 times 1.5 is 6. He's got 6 kilograms, which means he needs 4 kilograms. Now we've got to work out how many bags he's going to have to buy. Because they're in 1.5 bags, 1.5 plus 1.5, that's 3. That's not enough. If we add another 1.5, that will give us 4.5. It's more than we need, but we've got no choice. We are going to need to buy 3 bags. And then 3 bags at £3.65. And I think for that one, I'm going to write them in a column. And I'm really just trying to demonstrate the different ways you can approach this. There's no hard and fast rule, is there? And our answer is £10.95. Okay, so the key word here is estimate. It's not uncommon to see a question like this on a non-calculator paper. So if you've done lots of past papers, you might look at this and just launch straight into doing it. However, that word was there, which means even if you did a perfect job at working out 85 times 26.9, you will not get any marks. You are expected to round. So our 85 rounds to 90. Always best to go with one significant figure because then you are making things as easy for yourself as possible. So 26.9, a lot of people would say that rounds to 27. It's not wrong. It does round to 27, but 90 times 27 is not that easy. So this is what I mean when I say round to one significant. This is 2. If I go again with the rounding, I'd end up at 30, one significant figure. Now 9 threes are 27, add the 2 zeros, and we've got our estimate. This question is not an estimate. So this one we actually will have to do. So let's set it up. It's a division, which means it's going to go into our bus shelter. Now, at this stage, our alarm bells should be ringing. We don't divide by decimals. I actually need to get rid of this. The only way to get rid of the decimal is to multiply it out. I'm going to need to times that by 100 in order for that decimal point to move itself along and out and give me the number 18. However, whatever I do on the outside of the bus shelter, I do to the inside. So that's going to end up becoming 687.6. Now I'm dividing by the 18 times table. What I'm going to do is just take a minute to list out a little bit of the 18 times table, and then I've got it ready for the calculation. Now, if I double my 18, it's going to give me 36. So I know that's 2 times 18. If I add these two, I'll get 54, and that's my 3 times table. I'm now looking at this row. If I double this, I will get the 4 times. So double 2 is 4, double 36 is 72. I could double that again and get the 8. I could double the 3s to get the 6. I could add the 1 in the 4 to get the 5. Whatever. I don't know at this stage. I've just got myself started, and now I'm going to return to the problem. I've got to do 18 into 6, which obviously won't go. Carry that 6, and now I'm doing 18 into 68. So I can see from my list that that will go 3 times, and I need to see what's left over. So 68, take off the 54, and that gives you 14. So I'm carrying 14 over to the 7, which isn't going to make it very easy to see. So I'm just going to pop it underneath. I've got 147. Now that's significantly bigger than what I've got so far. But I am kind of looking here, 147 and I've got 72. If I double this now, I will have 144, and I am very close. So I'm going to put up my 8. 147 take away 144 is 3. So I've got 3 left over, which goes and sits on the next digit. I have hit the decimal, and the minute I hit the decimal, I pop it up on the top of my bus shelter, and then 18s into 36 go 2. So my answer is 38.2. Okay, we have a train company increasing its ticket prices by 5%. This 5% increase adds £8.56. And you've got to work out the new price for a ticket from London to Birmingham. So what we know from the story is that there was an original price and £8.56 gets added to it to create the new price. So that's one way of looking at that. I have got to work out what this original price was. Now, it's really easy to miss this in the question. It's increasing by 5%. This increase adds. This increase of 5% is 8.56. And that's how I need to view this. 5% is worth £8.56. The original is me getting all the way to 100%. So I'm going to double. That's giving me 1712. And then I can just times that by 100. Sorry, times that by 10 to get to 100. And timesing by 10 is just moving that decimal point one place. You could have done 5. You could have taken that 5% and multiplied it by 20 and gone directly to 100. Again, there's no perfect way. It's just the way that you see it. So the original ticket price was £171.20. Our 5% increase was £8.56. So the new ticket price is £179.76. we are being asked to add these fractions and give the answer as a mixed number. So I said this earlier with the division. When they want you to do more work, they really, really make it clear. Now, these are mixed numbers. All of my fraction methods are fraction methods. They are for fractions only. So I need to change these. So 4 times the 2 is 8. Add in the top, and you've got 11 over 4. We don't have a mixed number for the second, so we've just got what we need. I'm going to use the bus shelter. You use whatever method. Did I just say bus shelter? Smashed window or broken window is what I'm going to be using. The 11 and the 4 go along the top, 3 and 10 down the side, and you multiply in. This is always your denominator, and you either add or subtract if it's a take question, those two. Now we've got an add. 110 plus 12 is 122, and that will be over 40. But remember, we want simplest form and we want mixed number. Now they're quite big. I'm just going to go straight into halving those. So I'm going to do a little bit of cancelling. Half of 122 is 61, and then we've got our 20. Now 20s into 61 go 3 with 1 left over the 20. And that's our final answer. Okay, we've got a pretty big question going on here. The area of the triangle is equal to the area of the rectangle. Work out the difference between the perimeter of the rectangle and the triangle. So I've got to do a little bit of work using my knowledge on area before I'm going to be able to answer the question. If I'm going to find the difference between the perimeter, then I need the perimeter of both shapes. At the moment, I can't do that because I don't know what this edge is, and I don't know what this edge is. I'm going to need to work out what X is so that I can go on and find out this edge and then go on and answer the question. So the first line is what is going to help me. They're saying that the area of the triangle is equal to the area of the rectangle. Now, the area of the rectangle is base times height. So it's going to be 10 times 3x, which is 30x. The area of my triangle is base times height. So that is going to be 15 times, and then the height, which is 2x plus 4. Now it's all of this that has to be multiplied. So you're going to times the 2x by 15 to get 30x, and times the 4 by 15 to get 60. And then you divide by 2 because it's a triangle. So that's going to lead to 15x plus 30. They're telling us that these two areas equal each other. So the area 30x of the rectangle is equal to 15x plus 30, the triangle. Bring the x's together by moving the smaller set of x's. So I'm going to hop that over. It's going to land as negative 15x. And now I've got 15x equals 30. Divide through by your 15, and you've got x equals 2. Now I'm going to substitute that 2 into the algebra on these edges so that I can work them out. So 3 times 2 means that this edge is 6. And 2 times 2 plus 4 means this edge is 8. I can now work out the perimeters of these shapes. So the perimeter of the rectangle is 6 plus the other 6 plus the 2 10s, which is giving me a total of 32. And the perimeter of the triangle is your 8 plus the 27 plus the 15. You may need to put these in columns, or you may be just fine. That equals 50. The difference between those two is 18 centimetres. Okay, we've got the first 5 terms of an arithmetic sequence, and we've got to write the nth term. So we need to see what it's going up in. To get from -8 to -2, we add 6. And if you're not comfortable or confident with your negatives, you could always go up to one of these positive ones and double check to see if that's still working. The gaps, the number that you find by looking at the gaps, is the number you squash to the n. Now we're going to do the opposite. We're going to go to that first number, go in the opposite direction, which means we're going to end up taking away 6. -8, go down another 6 places, and you are at -14. And that is the part that goes on the end. I see lots of students sort of muddle between the two. So gaps are squashed, and then that last step is the last thing that you write down. Okay, we're being asked to reflect the shape in the line y equals -1. So job number 1 is to put that on. This is my y-axis. My -1 is here. That's just a point, which is not a line. The line goes through that -1. And then we reflect. Now you can use your tracing paper here. If you were to use your tracing paper, you lay it completely over, trace your shape, trace your line, and make sure you put a marker on it. I have a video, actually I'll get it so that it pops up on the screen now, that shows you how to use the tracing paper for these types of questions. If you're not, you can do the count method, which works on horizontals and verticals, where you just say, okay, that corner is 1 away, so my new shape will be 1 away. This is 2 away, so my new shape will be 2 away. So you work out where it all goes, and then you can draw it in. And I've done it quickly. You, I hope, would use a ruler. Okay, so we're being asked to complete the Venn diagram. The symbol here just means that this is everything that needs to be included. And in this question, it's all the even numbers between and including 20 and 40. Now, the first thing I do is write them all out. That way we can cross them off and make sure that we've got everything that we want. I'd also write out the multiples of 4. And then we want to pair up and get the middle section done first. So I can see that 24 is in both sets. I can see that 28, 32, and 36 is. And then I would cross those off my main list as well. So 24, 28, 32, and 36 are in. Now, the leftovers for my multiples of 4 are 20 and 40. And for B, we've got 22 and 30. I can now clearly see the ones that I've not crossed off my main list. I've got 26, 34, and 38. So they will go into the rectangle section. And that is us done. We're then being asked to find the probability that this number is in the set A, and then we've got this symbol B. Now I see this as U for united, A and B together. So it's all of the numbers in all of the sections. And we've got 1, 2, 3, 4, 5, 6, 7, 8 out of a total of 11. Please remember, when you read probability, you need to be thinking fractions. Our answers are always fractions unless the probability question itself has given you some information in decimals. So you must be thinking fractions when it comes to that word. Okay, we're being asked to write 240 as a product of its prime factors. So we're going to split and write down 2 factors. Now, how you split and the 2 factors you use may be different to me, and that's absolutely fine. We all see things differently. There's no right or wrong way here. I'm going to do my 10 next because I can see it's nice and small. It's going to go straight to some prime factors and I can be done and dusted with the 10. Now 24 is going to be 8 and 3. And I've got another prime factor. You may do 6 and 4. As I said, it does not matter. And then for the 8, I've got my 4 and my 2, and then my 2 and my 2. And I have 2 to the power of 4 times 3 times 5. Now we're being asked to find the highest common factor of 240. So it's the same number as the first part and 112. So we're going to use the then method for this. To do that, I am going to need the factors of 112 as well. So I'm just going to quickly work those out. And from above, I could see that the 8 went to 3 2s. So this is my 112. This is my 240. I am going to match in to the middle any that are common. I'm also going to list these out so that I can see them really nice and clearly. I won't relist these because I can see those already. So this 2 can pair up with that one. And I'm going to keep going until I have found them all. There is no 7 common and there's no 3s and 5s common. So that's completed. Now, technically, I didn't need to complete it because the highest common factor is actually just the middle section here. So that is 2 times 2 times 2 times 2, giving us a final answer of 16. I filled it in completely just so that I could remind you that if it had been an LCM question, you would be expected to multiply all of the sections. Okay, our indice question. You have to be very careful here. We drum it into you that anything to the power 0 is equal to 1. And they've only got to do a slight thing and it could throw you off. If you've automatically put 1, you will be wrong because this is 5 times x to the 0, which means it's 5 times 1. And the answer is 5. The most common mistake here is that people do 2 cubed, which is 8, but then they call it -8, which is incorrect. 2 cubed is 8. The negative actually means reciprocal. And a reciprocal is a bit like, you know, your keep change flip in dividing fractions. That flipping that you do on the last fraction is a reciprocal. A reciprocal is a flip. So if I just put this over 1 to create the fraction, I can then easily flip it and get my answer of an 1/8. And here I'm just going to be using my knowledge of indices. So I know that this is added because of the times rule. I know whatever this answer is, it will get taken away from here to produce this. So I've got a number I don't know, and I'm going to just call it x at the moment. I don't want to call it n. So something take away 4 is equal to 7. That tells me 11. So I've now got 5 to the power of 3 times by 5 to the power of something equaling 5 to the power of 11. So my n would need to be 8. And I can then check that I haven't made any mistakes by just redoing the whole thing. 3 plus 8 is 11. 11 take 4 is 7. It's all working an absolute treat. Okay, now I do quite like this type of question. It's not massively common. I appreciate that. The reason that I like using it and making sure that my students see it is because I don't want them to lose the formula triangle for regular polygons. You can sometimes get around a regular polygon question without it, But honestly, it's the best thing ever. You read that word regular, it triggers this triangle. 360 at the top, side or sides, I just don't have room to write the whole thing. And that X is for exterior angle, okay? Like I say, there are some instances where you can get by without needing this. But this is an example of when you absolutely cannot. If you don't have that up your sleeve, you're going to really struggle to answer this question. And that's why I throw this every now and again at my students, because it's forcing them to realize just how important this triangle actually is. Now, this is a polygon. I don't have the entire polygon. Obviously, it must keep going and it must join up, and it's got a certain number of sides. I just don't know how many. If I knew the exterior angle, I would just be able to divide it into the 360 and find my sides. This is the interior. The exterior sits on a straight line. So all I need to do here is 180, take away 144, which is 36 degrees. And then I take the 360, divide it by 36, and I've got 10. I'm being asked the name of the polygon, so it's a decagon for a 10-sided shape. So a fairly straightforward one and a fairly nice regular question as far as the numbers go. At this stage in a past paper, they're usually trickier, aren't they? But really threw it in there to get us all aware of this again. Really massively helps. Okay, there are 8 boys and 12 girls in a class. The class has a test. The mean mark for the class is 36. And the mean mark for the girls is 45. And we've got to work out that mean mark for the boys. Now, it's pretty obvious. Mean is the key word here. And how do we find the mean? We add everything up to get a total. And then we divide that total by how many are there, all the numbers, let's say. That's what equals the mean. So even though when we talk about the mean, we think about it in the form of a sentence, add them all up and divide by how many are there, the reality is it is a formula. You add to get a total, you divide by how many are there, and you get your mean. And that is what you're going to use to make this a very easy question to answer. So the mean mark for the class, there was a total for the class. I don't know what it is, but there was a total. And when it got divided by 20, because that's how many are in the class, the boys and the girls together, it gave a mean of 36. Now, if I get my t on its own, by moving the 20, it'll land as a times. It will tell me that the total for the class is 720. I'm never going to know all the individual marks for each student, but I can work out some totals. I'm going to do the same for the girls now. So there's a total I don't know, but when it got divided by the 12 girls, it gave an answer of 45. So I rearrange and I need to times 3 by 12. Now, this I'm going to need to do a little bit of working out. So the total for the girls is 540. Now, the reason that's significant is it means just by taking away the girls from the entire class, I can get the total for the boys. So 720 take away 540 will give us 180. So 180 divided by the number of boys is going to give us that answer. Now I'm going to use my bus shelter to help me here. Now, when I get to that point where I'm putting a remainder and it's not really attaching itself to anything, that's when I know to add my 0 and add my point. and then 8s into 40 go 5. So the mean mark for the boys is 22.5. Okay, so Jamie is saying that the two lines that we've been given are parallel, and we've got to decide whether he's correct. When it says give a reason for your answer, I mean, really, we're going to have to do some maths here, and a lot of that maths is going to work out as being our reason. Parallel lines. So if I had a line, the line that's parallel is an equal distance apart. The steepness of these two lines will be the same, or they wouldn't be parallel. So their gradient is equal, and that's what they're really testing here. Is the gradient of these two equations equal? We can see in the first that we have got a -3 gradient. The gradient always sits in front of the x. But this one has a +3. But it's not in the same form where it says y equals and then everything's on this side. So if we take the 2y plus 3x and we just move that across, that's going to leave the y's on the other side. Now, at this stage, you might be tempted to say he is correct because they're now both -3, but I don't have a single y yet. I want these to look the same. That's got a y on its own, so this must have a y on its own. And of course, the minute I move that across and divide by 2, I'm going to mess this up. My gradient is actually -3 divided by 2, completely different. So the answer is no. They want a reason. Your maths is there and it is clear, but it would be really good to put it into a sentence as well. So no, equation 1 is -3. Equation 2 is -3/2. Not the same. So not parallel. And that's it. I really hope you have found this useful. Keep your eye on the channel. We will drop in that paper 2, paper 3 collection. I will be writing those questions, as I said, so they will be brand new and enable you to be revising things you haven't seen before, which is what your GCSE is going to feel like. If it's been helpful, please like and subscribe. It really helps my little channel get out there and find more people to support and help with their maths.